Today we're going to program your virtual robot in VEX Code VR, which is this platform here. And we're going to program it to move in the labyrinth challenge, the same challenge that you did months ago in school. In school, you programmed your robot to move based on time. If you needed to move longer, a further distance, then you had the robot move for a longer period of time. If you needed the robot to turn more, then you programmed it to turn for a longer period of time. But in this assignment, I'm asking you to meander through the labyrinth challenge by using distance and also by using whiles and if-thens. So VEX Code VR looks like this. If you go to Google Classroom, it's this assignment here, the Labyrinth Challenge, using the while and shaft encoders. If I click on it, here's it's spelled out. If I want to see what the Labyrinth Challenge layout looks like, I click on that, the PDF. And you may recall this. Your robot needs to start behind the line, meander this way, cannot cross one of those black lines, and needs to end up here where it says number 2. All right, so if you go to VEX Code VR, it will look something like this. If we click up here in the right-hand corner on Playground, then it shows you the playground. I'm choosing the grid map playground, and that's you want a grid because the grid gives you locations in X and Y. Okay, so this grid is like a grid in math where there's an X and a Y axis. The X runs from negative 1,000 down, sorry, the Y runs from negative 1,000 down here to positive 1,000 up here. The X likewise runs from negative 1,000 on the left to positive 1,000 on the right. All right, so how do we do this? All right, so we need this robot to start in this corner here, as shown earlier in the Labyrinth Challenge field. So why don't we do that today? Why don't we simply get the robot over to the starting point? All right, so these statements in blue are functions that move the robot. These functions are printing, appearance, looking things. These are conditions controlling the robot. These are different types of sensing functions, operators that we can use in conditions, and variables. All right, so you need to keep doing something. And a function that does that well is the while loop. So here we have the while loop at the end. You'll notice that it has a tab at the top that's cut out, and it fits into this tab where when started. So if you're looking in VEX Code VR to put two parts of a program together, then look for something that fits. All right, so while loops do what computers do well. They keep doing the same thing over and over again. So what do we want to keep doing over and over again? Well, we want this robot to move until it's in this location. So this location is a little higher than negative 1,000 for Y, and it's almost 1,000 for X. So why don't we put in a condition here while this condition is true? We're going to move the robot. Why don't we put a condition in here that says while we haven't reached this status, keep moving. Or while the status is not this, keep moving. All right, so what's an example of that? So if we scroll down here, we find we're looking for something that looks like a hexagon, some condition. And this is both an X and a Y coordinate for this starting position. So why don't we do something that is an and condition or an or condition? Well, two conditions have to be true or not. So let's move this one here, and you'll see that it's a hexagon shape. And when I place it near the hexagon in the while loop, lights up, and it will fit into that spot. All right, so what are the two conditions upon which we would want to keep moving? Well, how about the X condition? We want X to be, let's say, 900. So if X is less than 900, how about this one down here? Don't we want to keep moving? You'll notice that that first hexagon is lit up in the OR statement. Okay, so what could go in here? Well, again, we're talking about X, right? So let's see if we can find the position X that the robot's at. You'll notice this has an ellipse shape just like this here in the green function, and so that will fit in there. All right, so now what we're doing, what this part of the condition is that while the X location of the robot is less than something, well, how about less than 900? If it's not 900 yet, I'm moving here from a very small number like negative 900. If it hasn't reached 900, then I'm going to keep doing something. Maybe I'm going to keep moving. Okay, how about the Y? So the Y, our final Y location for our starting position is, let's say, is negative 900. Well, so when do we want to keep moving? Well, when the Y is greater than that negative 900. This looks like this would be the appropriate condition to put in, because if it was equal to 900 or was less than 900, I would probably be in this corner. So I probably want to stop moving then. So as long as Y is up here, greater than 900, I want to keep moving, which is the functions I'm going to put in down here. All right, so what do we want to put in here? Similar, a position, the position of the robot. I'm going to change X. Here, let's just get this out of the way. Here we're going to change X to Y. And again, instead of greater than 50, how about greater than negative 900? Okay, so now, while the robot is off from this starting position, meaning it's not positive 900 for X, negative 900 for Y, it's going to keep moving. Okay, but that means we have to tell it to keep moving. Well, when do we want it to keep moving? Or let's maybe better ask, in what way do we want to keep moving when one of these conditions is true? How about using an if? An if-then statement or if-then else would allow us to make specific choices for the movement if a certain condition is true. So why don't we grab the if-then else and put that in there, in the while, and keep asking every time the while loop revisits if a certain condition is true, and then if a certain condition is true, then we will do a certain type of movement. All right, so how about let's choose one of these two. How about if X is less than 900, like in this case? So again, we want to move the X position in there. The robot has been sensed. We are sensing whether what position the robot's at. We're asking the question, is it less than 900? If so, here's one strategy we could employ. If we're not here where X is 900, how could we get there? Well, so we don't know what our Y is yet, right? If we knew we were right here, we would simply turn, like a human being would turn to the right and just go straight forward and then stop, right? But we don't know what the Y position is. And what if it was here, halfway up, 0? Or what if it was near the top, a Y of positive 900? Would we want to do the same types of motions? So maybe not. So one way to do this is to move in circles, but spiral. So you're kind of moving closer and closer to something unless you need to adjust. So why don't we put both a move forward, like this one, in here, and then why don't we also turn for at a certain angle so that we could spiral and potentially get to this right corner. So maybe, I don't know if this is the right number. Well, let's move forward for 200 millimeters. Let's turn, but maybe not turn too sharply, something like that. So this would happen if X is less than 900, is a negative number, is 0, or is 20, some small number smaller than 900. We're going to make this motion. All right, what if we are greater than 900? Well, then we won't be in this loop. And so there's probably no need for an else in this case. We could have done a simple if then. Because well, actually that is not true. So if either one of these conditions is true, we will be in this while loop. So I think we do need an else statement. And it should probably be something like the opposite of this. Instead of maybe driving forward, we're too far over here, maybe drive in reverse, maybe take a left turn. So let's put those in. I put that in the else part if this condition is not true. I'm going to turn as well. But instead of going forward, we're going to go in reverse. Instead of going right, we'll go left. And maybe that 20-degree turn is not a bad turn. All right, we can try this. We can test this. Here, let's make our playground larger by clicking on expand. Let's play it. And watch when I play this, there'll be a yellow outline around whichever statement is being run at that time. Do you see the yellow statements? So we're still in this place where x is less than 900. And so you see what's happening here. We're probably going too far off the field and probably won't bring us back on. So there's something maybe not ideal. So let's stop our program and reset it. Okay, so maybe there's something wrong with this. Maybe we need to add something about the y position. So couldn't we add another if then below the x if thens and make it just like this one, but with y's? And the answer is yes. If then else could go underneath this else. And again, I can put in all this same stuff, but for y. But again, I'm going to do a greater than value for y. Whoops. We're going to use the y value of the robot. So I'm going to change this to y. Change this to negative 900 while we are too high up. Keep doing something. And maybe the things we want to do are drive forward. Keep looking for that ideal start location. Again, maybe 90 degrees is too big. So now again, if we're too high up, we're going to move forward and we're going to turn right. We're going to do that spiraling. Okay, but what if we're too low? Or, yes, too low. Then don't we want to maybe do what's the opposite like we did here with the x? So let's put this in for our y. If our y condition is not satisfied, and then turn if our y condition is not satisfied. Again, I think we want to do an opposite motion, like maybe go in reverse and turn left if we're too far. And maybe something like 20 degrees would be better. All right, let's check out this. You'll notice it's staying in the x. Oh, but we are getting some y statements here too. It looks like so we still have a similar problem where it's going off the field. But I think you're getting the idea of how we could maybe find a starting place. Make sure you save your file by clicking on File and then Save to your device. Thank you for listening.